So, hello, everybody. Welcome, welcome. Glad that you're joining us here today for this pollinator gardening and insect conservation webinar. So, we're really doing this in order to get the word out about the Great Florida Pollinator Census. So, we'll talk to you all about that and how you can participate this year and years going forward. But what we decided to do is educate you a little bit on some pollinator related topics. So, each of us, we have multiple speakers here today from IFAS Extension. Each of us is going to cover about 15 minutes of a topic, and we'll start off with mine, which is pollinator-friendly pest management. Then we'll learn a little bit about parasitoid and beneficial insects from Caitlin Salazzo at Manatee County, insect conservation from Cheryl Vanderheiden over at Lee County, the top 10 pollinator plants for Southwest Florida with Tia Silvesi, who is at Hillsborough, and then we'll kind of wrap up with strategies for a pollinator-friendly yard, and the 2025 Pollinator Census with Forrest Hecker, also with me at Sarasota County Extension. So with that all said, I'm going to go ahead and start off with this talk, which again is pollinator-friendly pest management. So I'm Jackie Leibowitz. I'm the chemicals and the environment agent at IFAS Extension, Sarasota County. So I teach people all about insects and how to manage them and whether they even need to be managed, which little spoiler alert here is not always going to be the case. So we're going to briefly talk about pollination so that we're all on the same page. Context is important. We'll go over common insect pollinators, common insect pests. We'll talk about integrated pest management, or IPM, which is essentially the core of what it means to do pollinator-friendly pest management. And then we'll go into some more specific pollinator-friendly pest management tips, and then I'll pass it on to the next speaker. So, pollination. It's actually estimated that over 90% of flowering plants require pollinators. So if we didn't have pollinators, we would lose foods like almonds, apples, bananas, chocolates, just to name a few, and of course, coffee. So those are just a smattering of crops that we have that do require that pollination. And so really at the key to the survival of crops and these agricultural systems is the honeybee, which you may have heard of, Apis mellifera. And although we have the honeybee that helps us with all this agriculture, there are so many more pollinators that we have right here in Florida that we're going to talk about. All right, so this is just a very small little sample of what you might find here in the state when it comes to insect pollinators. And yes, there are pollinators beyond just those bees. So when we talk about bees and wasps, they actually belong to the same order, Hymenoptera. So they're also related closely to ants. Honeybees, bumblebees, carpenter bees, and so many more are going to belong to the family Apidae. And so there are thousands of bees within just that one family. We also have these gorgeous blue-green sweat bees that you'll often find hovering around flowering plants here in Florida. Leafcutter and mason bees, which are very interesting. They create these little structural nests for themselves out of natural resources. We also have spheicid wasps and plenty of other parasitoid wasps that Caitlin is going to be sharing more information with you about in a little bit in our next talk. Then we also have flies, which, believe it or not, are extremely efficient pollinators. Some argue maybe even better than the bees, especially in our wild systems. So there's tachinid flies, syrphid or flower flies, bee flies, which I think are absolutely adorable. You can actually see a picture of one in that far right in the middle of those pictures to the right of the slide. Very fuzzy, very sweet. Beetles are maybe an unexpected pollinator to many. So we have soldier beetles, which I think are really interesting, and they belong to the Cantharidae family. And one of the most iconic of the pollinating beetles is the goldenrod soldier beetle. So if you've ever seen those big, beautiful golden blooms around the fall in Florida, the goldenrod soldier beetle is actually known to help pollinate those plants and spread them around. And beetles are actually one of the earliest pollinators that we have too. And there's also butterflies and moths belonging to Lepidoptera. So there are many, many different kinds of butterflies and moths. And what's interesting about them too is that they're active during the day and the night, depending on what species. So they help pollinate a lot of those nocturnal plants as well, those plants with nocturnal blooms that only open up at night. So there's the white peacock butterfly that we have all around the state, which we have featured in some of our promotional materials, and they belong to the brush-footed butterflies. And then we have skippers, which are tiny little butterflies that you might see around a lot, especially in our ground covers like sunshine mimosa. So there's a lot of different insect pollinators out there, right? And we consider these beneficial because they are performing that service for us of helping promote the existence of those flowering plants. Like I said, a vast majority of flowering plants need pollinators to survive. Now, on the flip side, right? And this is one of those things that we have to talk about because it, pests are a thing here in Florida, right? There are a lot of different pests, and people might not always be able to differentiate between friend or foe when it comes to insects in the garden. So we're just going to quickly go over insect pests and what a pest even is. So just a little generic definition here to help put it into context. Pests are really any organism that's going to pose health, environmental, economic, or aesthetic risks. Now, when we talk about landscape pests in particular, we can divide them up into two main categories based on their mouth parts. So this is going to inform how they feed on the plant and whether or not they can transmit disease. So there's that first bucket there, piercing, sucking mouth parts. And what you're looking at right there on the screen is a very close-up image of an aphid with its stylet, which is basically like kind of a sharp straw of sorts. So they use that stylet to pierce into the plant tissue and suck out the sap, so the sugary nutrients that the plant holds. And some examples of pests with piercing sucking mouth parts include aphids, like the one pictured, scales, whiteflies, and chinch bugs. Then we also have chewing mouth parts. So chewing mouth parts are going to belong to possible pests like caterpillars, leaf miners, grasshoppers, and mole crickets. Those are just some examples there, but they have these pretty intense mandibles that you can see in the picture there that they use to tear apart solid material. So they're not drinking that sap, but they are tearing apart things like leaves or wood as they're feeding. Now, less than 1% of all described insect species across the world are considered pests. So I hope that really puts things into perspective for you that most of the insects that we're going to encounter on a regular basis are either beneficial, so they're doing things that are important like pollination or perhaps even their own form of pest control, or they're harmless, so they're not posing any risk to us or the environment. So really less than 1% of all described insects are considered pests. Now, of these two categories, I want to have you pay special attention to the pests with the piercing sucking mouth parts because these are the pests that are associated with transmitting plant disease. So they're the ones that are going to require more management than others. Now, ID is key, right? We talked about some common pollinators, we talked about some common pests. I would be here for hours and hours if we were to go through each one and talk about those distinguishing characteristics so that you'd feel comfortable assessing what's what. So what I really want to impart to you is know how to identify or know who you can go to, what resources you can use for proper identification. So proper identification is important because why? And you're welcome to post a guess to the chat if you'd like, but I'm just going to launch into it just in terms of saving time here. One, we are avoiding harming beneficial insects like pollinators when we identify the insect before we treat, right? So many times it turns out that we're not dealing with a pest at all. So if that's the case, right, why do we need to bother treating it? It's just unnecessary use of time and resources and potentially introducing something that's toxic into the environment. So we don't want to do that. You also want to make sure too, if you do have a pest problem, that you have the right solution for that problem. So not every pesticide is made equal. Sometimes they can be very specific. And so you need to make sure that you're choosing the right product or the right combination of tools and strategies to deal with that particular pest problem. And like I said, sometimes we don't have a pest problem to begin with. It could be that someone just saw a ladybug larva and they look a little weird and they got concerned because they were on this plant that they care about. But turns out they are beneficial and we do want them there. And identification is what we consider the first step in integrated pest management, which I'm going to cover in just a moment. Now, I want to make you aware of some helpful resources. The first thing is going to be the Featured Creatures EDIS collection. So it is a collection of EDIS publications. These are just short written online articles that go over some of the common insects you might find here in Florida. And there's also the UF IFAS bookstore. So if you are someone who's outside a lot and you like field guides or books or anything of the sort, you can buy a lot of materials from that bookstore. And then if you decide you need some help with identification, if you're uncomfortable trying to make that distinction between pest and beneficial, ask your local extension office for help. And the other option too, if they don't have a designated entomologist or bug person on staff, you can submit a request to the UF Insect ID Lab. And there's a small cost associated with that, but you get some really great information. So you have to think of yourself as a little bit of a pest detective, right? When we're going about figuring out what the problem is and how to tackle it. That identification is really going to be the most important thing. And so it's the first step, as I mentioned, of integrated pest management. So, what is integrated pest management? You're basically using a combination of steps and strategies to suppress pest populations to an acceptable level. What does that mean? Well, if we tried to get rid of every single insect in the landscape, it's not very practical. It's not very feasible to do. And if it is, it's probably going to be very expensive. So we're really just trying to get those pest numbers to the lowest possible that they can be so that we're not having to deal with the effects of the pests. And remember, a lot of insects fly. So you might get rid of that population there, but that's not going to necessarily prevent more from coming in. It also really focuses on prevention versus reacting to a problem. And by using these different steps and strategies, we're overall reducing the need for pesticides. When we do have to intervene and solve a problem, we are opting for lower impact strategies. And that is a big part of integrated pest management, is always trying to find the lower impact solution first before we move on to things that are higher impact or may have more effects on the environment and ourselves. So because of this, it's considered very pollinator and wildlife friendly as a practice. There's 5 main steps involved in integrated pest management. There's identifying the pest, as we've gone over. There's monitoring the population, so figuring out how many are there, and if there's a lot, maybe it's time for you to jump in and determine when it's a problem. So the action threshold is when you decide to take action and figure out your management strategies. Speaking of which, step number 4 is to use IPM strategies. So it's a combination of tools and what I consider the toolbox, which we'll look at in just a second, that you can use to, again, reduce your need for pesticides and really think about why is the pest there and how do I make the environment less favorable to the pest. And then after you do all that, evaluation is that last and really important component of IPM, because you could do everything you think is right and the pest population doesn't go away. Maybe it even increases. And so you have to figure out what happened and steps that you need to take to correct that issue. So I mentioned those IPM strategies or tools. You may have heard these before. There's cultural, physical, mechanical, biological, chemical. Cultural is very much focused on doing things like watering and fertilizing properly, maybe not scalping your grass so that it can grow and get enough nutrients from the sun through its leaf blades. Physical mechanical is using tools or machinery to remove or reduce pest populations. Biological is basically using a living organism to help. So that could be more microbial, or it could be something like a predatory bug or natural enemies that already exist in the environment. And chemical is referring to pesticide use. So figuring out which tools you want from the toolbox to use together synergistically to tackle the pest problem is what integrated pest management, or IPM, is. So I'm going to kind of finish off my presentation here with some pollinator-friendly pest management tips, if you will. So, of course, just to drive the point home, you want to practice that IPM, or integrated pest management. It's really a mindset, and it might seem like a lot of work, but I promise you it is the most sustainable, cost-effective, and time-effective strategy for long-term pest management. Because you can spray something and get rid of pests, but that's not going to guarantee that they will stay away. Something has to change in the environment for them to not be as attracted to that space. If you do need to use chemical intervention for any reason, always try to opt for those low impact pesticides first. Biorational products are generally going to be less toxic, but the rule of thumb is anything you apply, you have to read and follow the label for, to make sure that you're using it for the right situation and the right pest. You want to avoid any chemical applications during active foraging periods. So I like to think of the worker bees as going out from 8 to 5, kind of like us, many of us. So if you can avoid applying pesticides during that time, and also when there's active blooming, that can be very helpful in terms of reducing that exposure to bees and other pollinators. Don't buy plants that have been treated with harmful systemic pesticides. Just one example I have are the neonicotinoids. There are some neonics that are actually a little better than others, but the point is when they're systemic, they stay in the system of the plant. And so that things that are foraging or feeding from them end up dying or experiencing some really negative side effects. So ask about the pest management routine at the nursery that you shop at, or I guess I should say, shop at local native nurseries. So you can go there, and chances are, if they're local and they're smaller, the staff is probably going to be a lot more familiar with what they're doing to manage pests. And you can also just avoid pesticides in general. So create these pesticide-free zones for your pollinator garden. And if you have somebody else who's maintaining that space, make sure to add clear, legible signage so that you don't have to worry about accidental sprays. All right, so some bee sources, which I will post to the chat momentarily. And other than that, I think we're ready for our next speaker.